Hello folks, welcome to another episode of, in fact this is the first episode of Data Science Tips, and today we are going to talk about loops in R. So in data science you often have to work with large data sets and you might have to do some analysis, apply models, I don't know. But one of the requirements is that whatever you're doing should execute quickly. Your functions have to execute very quickly on large data sets. Um, and data scientists often complain that R is very slow, right? Now, one of the culprits that could be slowing down your function could be for loops. For loops are notoriously slow in R. R was not designed to execute for loops. In fact, it is just there because a lot of programmers are very comfortable with for loops, but it's not very efficient in R. Okay, I'm going to show you an example. So let's say I have a random sequence of 1 million elements. Okay, so I just created a random sequence of length 1 million, and it has some random numbers, and what I want to do is for every element I want to find the average of the current element and the previous element. Now obviously I can't do that for the first element because there wouldn't be anything before it, so what I'll do is I'll just divide that number by 2. Okay, so this is what I want to do. So what I did was I created a sequence of indices that goes from 1 to 1 million. I'll use this to access every element in the sequence, and I've created a placeholder for the resultant. So this is just all zeros, a million zeros. So as I calculate the averages, I'll just keep replacing this result. So I've written a function to do that. So as I said, so I wrote a for loop that traverses through the indices from 1 to 1 million, and for the first number I just divided by 2. So I just take the first element of the random sequence divided by 2 and store it, and second element onwards I take the average of that element and the previous element. So you can see this is what this does, right? So I'm just creating a vector with this current element and the previous element, and then I'm taking the mean. Okay, and now I want to know how long this function takes. The way to do that in R is to use system.time. So as an argument to this function, you can just supply the statement that you want to execute, and it will tell you how long the statement is taking. So let's find out. So what I'll do is I'll just load all these things. So I'll just put this in the workplace. I'll load the function, and let's see how long this function takes. Okay, executing. All right, so it took about 5.6 seconds. Okay. Okay, can we do this faster? I mean, is there any alternative way of doing the same thing? Here's a trick that I tried. Okay, so what I did was I created a shifted version of the same random sequence. All right, and the way to do that is just, okay, so I took the elements from index 1 up to index 999999, and then I put a 0 in front of it. All right, so that's how I created a shifted version. And then I created a matrix that contained the original sequence in the first column, and in the second column it contained the shifted sequence, and it is a matrix of 2 columns and a million rows. So as you can imagine, what would this matrix contain? What is the first row? So it will contain first element of the random sequence and then 0. The second row would contain the second element and the first element. The third row would contain the third element and the second element. Okay, and now what I want to do is I want to find the row-wise average. That will give me the original average sequence, right? So the way to do that with matrices is to use an inbuilt function called apply. What it takes as input is a matrix and something called a margin. So margin equal 1 implies that you want to apply a function row-wise, and margin equals 2 applies that you want to apply the function column-wise, and the function that you want to apply is mean. So if I say a random matrix, comma 1, comma mean, it will give me the row-wise averages. Okay, Same, it's just another alternative way of doing the same thing. So let's see how long this takes. I'm just exploiting an inbuilt function in R to replace the for loop. So technically it is possible to not write a for loop and instead use some inbuilt function in R. Let's see how long this takes. So I'll just load the function and see how long it takes. Executing. Oh, it took 8 seconds. So it's not necessarily faster than the for loop. Still takes quite a while. But does it give the same results? Let's see. So what I'll do is I'll just look at the summary of the original mean sequence that I got through the for loop and the sequence that I got through this alternative method. Now, this is a way to check whether two sequences are same. Right? And you can see it's all 0. So the minimum is 0, maximum is 0, average is 0. So what does this mean? All the elements in this sequence is 0. So they are exactly the same. These sequences are identical. Okay, so it gives the same results, but it is slower, or it has comparable speed. How can I make it faster? Now, if you think about it, what is an average really? So you're adding two numbers and you're dividing it by 2, or you're multiplying each number by 0.5 and then you're adding them. And one way to achieve this is to use matrix multiplication. All right, so suppose I have two numbers, say 2 and 3. The average is 2.5. What I can do is I can just do a dot product of this, and the way to do that in R is using this. So percentage multiply percentage. So that's what does a matrix multiplication. And I'll do a dot product with 0.5, 0.5, and I get 2.5. Now, how do I do this for a million elements? I want successive means. So how can I achieve that? I'll do the same thing which I did in the previous example. So I'll create a shifted version. I'll create a matrix, and what I'll do is I'll just cross multiply this matrix with vector 0.5, 0.5. So it has 2 rows and 1 column. So if I multiply a matrix with a million rows and 2 columns with a matrix that has 2 rows and 1 column, the resultant would be a matrix with a million rows and 1 column. So I will get exactly the sequence that I'm looking for, the sequence of successive averages, right? Let's give it a try. Let's see what happens. I'll load the function. And it's instantaneous. See, it takes only 0.046 seconds. So 10 times, more than 10 times faster than the for loop. And does it give the same results? Let's find out. So I'll do the same thing again. I'll just look at the difference and sequence vector. What's the summary? It's all zeros, so they are identical again. So the point is, you can replace for loops in R, and always try to avoid for loops. Use inbuilt functions in R, or the best thing to do is to use matrix and vector operations, because matrix and vector operations is what R was designed for, and that's what works fastest in R. So that's your tip for the day. Thank you.